My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 200. In this lecture, we are going to compare logistic regression and linear regression because it is very important to understand how linear regression and logistic regression are related. If you understand the relationship between linear regression and logistic regression, then it is easy to interpret the meaning of the logistic regression. We will compare linear regression model and logistic regression model. We will see the first relationship, I can say first difference between logistic regression and linear regression. Just say here, let me say what is your y1 here. I can say this y1 is dependent variable. It is dependent variable, isn't it? Your dependent variable is a continuous variable. What about x1, x2, so on, xn? x2, x1, x2, so on, xn are independent variables. These independent variables may be metric or non-metric. What is the meaning of metric? I can say metric means it is continuous, isn't it? Metric means what? It is continuous. What about non-metric? This is discrete. What is discrete? What is continuous? I discussed a lot on these variables in my previous lectures itself. What about your logistic regression? If you compare, again, this one is dependent variable. Is it not dependent variable? Yes, it is dependent variable. Which one is dependent variable? Your y1 is dependent variable. x1, x2, so on, xn are independent variables. What is the nature of this dependent variable? Dependent variable is binary. Non-metric means it is discrete. What about independent variables? They are non-metric and metric. Non-metric means, as I told you, this is discrete, and metric means what? It is continuous. If you carefully observe this difference between linear regression and logistic regression, there is only difference in terms of dependent variable. In linear regression, your dependent variable must be continuous, whereas in logistic regression, your dependent variable must be binary or non-metric, I can say. But in terms of independent variables, there is no difference. The linear regression model, but in the case of linear regression model, if the independent variable is discrete, then we can use concept of, if it is discrete, what you have to use? You have to use concept of dummy variable regression. Dummy variable regression. This concept I will discuss in future classes. Just time being, I will proceed further. This is one basic difference between linear regression and logistic regression. The another difference is, if you plot simple independent variable and dependent variable for a linear regression, you may able to connect all the points. Just say you can connect the points like this. Maybe you can connect a line which passes through maximum number of points. Otherwise, I can say with minimum error. You may able to connect all the points. But in logistic regression, value of y can be only two possibilities, 0 or 1. We will get this kind of relationship. This is about your logistic regression. This is 1. This one is 0. Only there are two possibilities, binary outcomes. That's what we were saying, isn't it? What is the meaning here? You cannot form linear relation. I cannot draw linear relationship just how we are drawing for linear regression. We are able to fit a line. Of course, there may be small error, but you cannot fit that line in the case of logistic regression, you can form a S-shaped curve, something like this. You may get something like S-shaped curve, isn't it? If you speak strictly, if your S-shaped curve is like this, isn't it? That's another, this is second difference between linear and logistic regression. What is that on y-axis? See, from 0 to 300. In the case of linear regression, your values is from 0 to 300. I can say these are actual values of your which variable? Your dependent variable. Whereas in the case of logistic regression, you have only two possible values, y equals 0 and y equals 1. These are in the case of linear regression, these are actual values, these are probabilities. Y equals 0 is a probability, y equals 1 is probability. This is one important difference between linear regression and logistic regression. Correspondence of primary elements of modal fit between linear regression and logistic regression. We used to just write this one, total sum of squares. We discussed about this particular concept in my previous lectures. What is this total sum of squares? I can say this is SST, total sum of squares for linear regression. The equivalent term for logistic regression is, what is that equivalent term? Minus 2LL. What is this minus 2LL? Log likelihood. What is LL means? Log. This already I discussed in previous classes. Log likelihood, isn't it? Minus 2LL, that is log likelihood of base model. Base model means without independent variables, isn't it? I will discuss what is base model after a few minutes. Here we have to write, I must say, that another difference, error sum of squares in linear regression. I can write error sum of square means I can write SSE, error sum of squares. The equivalent term in the logistic regression is minus 2LL of proposed model. What is base model? What is proposed model? I will discuss after few minutes. We know that in simple linear regression, in linear regression model, to test the overall model fit, we have used F-test. F-test is overall model fit, goodness of fit, isn't it? What is my F-test? F equal to MSR by MSE. This I discussed, isn't it? Which is equal to, in previous lectures I discussed about this concept, SSR by K by SSE by n minus K minus 1. K is number of independent variables, n is total size of data set. The equivalent test in logistic regression is chi-square test of 2LL difference. In simple manner, I can say this is nothing but G-test. In the case of linear regression, to test overall model fit, we are using F-test, whereas in the case of logistic regression, we are using G-test. Instead of saying this big sentence, just let me say G-test. You can say G-test. G-test is used to test overall significance of a model in the case of logistic regression. There is another difference, coefficient of determination, that is R squared value. We discussed a lot on this particular coefficient of determinant in my previous lectures. In the linear regression, to explain the model fit, that is goodness of the model, the term used is coefficient of determination, that is R squared value. What is my R squared value? I already discussed what is R squared value in my previous lectures. My formula is SSR by SST. What is my SSR? Regression sum of squares by SST means total sum of squares. Otherwise, I can say explained variance by total variance. The equivalent term in logistic regression is pseudo R square. I will discuss what is pseudo R square after few minutes. Time being, let me proceed further. Regression sum of squares. What is this regression sum of square? This concept also I discussed in my previous lectures in linear regression, that is SSR. Here we use SSR, regression sum of squares. The equivalent term for logistic regression is difference of 2LL for base and proposed model. What is base model? What is proposed model? That also I will discuss. I will repeat here in the case of linear regression, SSR, regression sum of squares, that equivalent term for logistic regression is difference of minus 2LL for base and proposed models. What is base model? What is proposed model? We will try to understand. We will discuss base and proposed model. Base model when there is no independent variable. That you must understand. What is base model? Base model means base model with there is no independent variable, I can say. There is no independent variable. Without independent variable, that independent variable, that is base model, isn't it? Base model means when there is no independent variable, corresponding log likelihood value is called base value. When you introduce any one independent variable, after introduction of independent variable, the corresponding log likelihood value is called model log likelihood. This is simple. I will discuss all these concepts after a few minutes. The fundamental difference between logistic, these values I discussed about this particular diagram in my previous lecture. Just try to recall. This is x comma y. This is, I can say, y. This value is y. This is, what is this? This is y cap. This is y bar. What is SST? SST is y minus. This is y minus. Y bar is SST. What is SSE? That is y minus. These concepts, I think I need not repeat again and again. Just go through my previous lectures. This, with the help of this simple diagram, I explained all those terminologies. Determination of coefficient. Before understanding this determinant of coefficient, the fundamental difference between logistic and linear regression is logistic regression differs from linear regression in being specifically designated to predict the probability of an event. This logistic regression deals with probability. Even though we can say probability value is metric, I can say, instead of saying many things, let me say, in the case of logistic regression, your dependent variable is probability. That may be this may be the simple way of explaining things. There is something like log likelihood. What is this log likelihood? I already discussed about this log likelihood in my previous lectures, but anyway, let me repeat this concept. What is this log likelihood concept? Actually, what it means, this one is measured used in log likelihood is a measure. It is a measure used in where? In logistic regression. In logistic regression. This, let me write point wise. This is my first point about log likelihood, and second point is measure used in logistic regression to represent the lack of predictive fit. What is the use of this one? To represent the lack of predictive fit. Lack of predictive fit. This is second point about log likelihood. So log likelihood is used to measure how much lack of fit is there. Even though this method does not use least square procedure in model estimation as is done in linear regression, the likelihood value is similar to sum of square error. This is just similar to sum of square error, SSE. Sum of square error where? In linear regression. I can compare. In linear regression, there is a concept known as sum of square error. This log likelihood is just similar to sum of square error in linear regression. The log likelihood value, I can say, if you have less, less log likelihood, less log likelihood value, then I can say it's a better model. Then it's good model. Then I can say it is a good model. If you have, then I can say it is a good model. When I can say particular model is good model, let me say the log likelihood value is less, then it is better, because in the regression we try to have sum of squared error is minimum. It is just similar to sum of squared error, isn't it? Similar to that, in logistic regression, if you are getting smaller value of log likelihood, then it is better. That is good model. That's what I'm saying. Mostly it is used when comparing models. This particular log likelihood measure is useful to compare models. To compare models. It is indicator of how much better one model fits than another model. It is a simple technique. Anybody can understand. I already discussed about this particular log likelihood measure in my previous lectures. These are few points which I want to keep here. Yes, linear regression. In the case of linear regression, you have R squared value. What is this R squared value? Coefficient of determination. This is known as coefficient of determination, isn't it? Coefficient of determination is measured by, how will I get? SSR by SST. What is my SSR? Sum of squares due to regression. What is my SSE? Total sum of squares. The equivalent term in logistic regression is pseudo R square. That another term for pseudo R square is, there is another term is for pseudo R square logit. R square logit function. That is, what is its value? I can say, how can I define this one? Minus, I can say minus 2 into LL. Here I have minus 2 LL null value minus of minus 2 LL model. This is null model. That's base model, isn't it? By minus 2 LL null. Where, what is LL? LL means, what does it mean? Log likelihood. Minus 2 LL null means it's a base model. Minus 2 LL model means it's a proposed model. Base model means without any independent variable, isn't it? That is just what is this model? This model means what? Model means it is proposed model. When you bring new independent variable into a logistic regression model, that time what was the corresponding log likelihood value? That is known as a model. That is known as proposed model. This is comparison between linear regression and logistic regression, isn't it? In the case of linear regression, just see, I will let me go to next slide and let me show output of your linear regression and logistic regression. Just see this screenshots I collected my previous lectures. Again, I need not spend time on this particular slide, but I am taking results from my previous lectures. In the case of linear regression, R square value 0.783. This is 0.783. That is R square value. In the case of logistic regression, pseudo R square. This is pseudo R square. That is 0.192. Isn't it? Here LL null. Where is your LL null? This is my LL null. LL null is minus 5.0040. What is this LL null? When there is no independent variable, corresponding value of log likelihood is minus 5.00040. That is LL null. LL means null means without independent variables. This is null model. I can say that is null model. This is base model. Null model or base model. They are of same meaning. Log likelihood model, I can say, so we have to find the difference. How can I calculate? Let me say like this. What is the formula? Just a minute. Let me calculate this particular value. Here What is that formula? Just refer my previous slide. There is a formula for calculating this pseudo R square value. What is that formula? Minus 2LL into this one, LL null value. What is my LL null value? Minus 2LL into, what is my LL null value? Minus 5.0040. Here you have this one, LL null. Minus of, otherwise I will write here. Just see. What is the formula for pseudo R square? My pseudo R square formula is minus 2 into LL null. What is LL null? Minus 5.0040, isn't it? Minus of minus 2 into, what is this? This one is log likelihood value, that is minus 4.0432, isn't it? By minus 2 into what is this LL null? LL null is minus 5.0040. If I simplify, what value I will get? In numerator, if I simplify, I will get 1.9216. In denominator, if I simplify, what will I get? I will get 10.008. If I simplify, what will I get? I will get 0.192. Just see, this is 0.192. This is the way how I calculated. I have a formula in my previous slide. Just refer my previous slide. There is a formula for finding this pseudo R square. Higher pseudo R square indicates that model is best model. These are few basic fundamental differences between your logistic regression and linear regression. Thank you very much.